Hi, I'm Noella. I'm part of Stream, and I'm going to be showing you a little demo of our D app. So, we're an expense management tool for companies, and the first issue that we wanted to address was the idea of managing payroll. So over here we have an interface for companies to add their employees and add their salaries, and then pay it to a smart contract where their crypto will be collateralized. And we use Flare time series oracles for the price feed, and it has functionalities where you can register and interact with the underlying smart contract. So over here is the view for the banks. Now they will actually be able to see all of the values because they need to know how much money in the real world to pay the employees on the company's behalf. And actually in the smart contract, all the values are stored as Petersian commits, so nobody will be able to see how much the company is paying their individuals or how much their coworkers' salaries are. And the nice property about Petersian commits is that they're additive and homomorphic, which means we can actually do mathematical operations on the commits, which is very useful for auditing, because now companies don't have to give up their actual internal data, and instead they only have to provide the commits to them, and they can be proved that they add up to the total balance. So we have also been experimenting with taking this whole concept of privacy to another level by, instead of just storing the committed allocated funds on the smart contract, but actually storing just one single value, which is the aggregated commit of all of the allocated funds in the company. So what we can do is actually generate a polynomial where each value in the vector is a coefficient, and then we can also derive a witness polynomial, which is related to that polynomial, and for each element in the vector, and then we take both the witness polynomials and the total polynomial, and we evaluate it at a point S, and then commit to that point. And so effectively we have a way for people to prove that they know an element I in the existing vector without ever having to know or prove knowledge of any of the other elements or the any of the other elements, or yeah.